In this video, I'll describe some of the techniques used to build artificial intelligence systems. There are some common techniques used in developing artificial intelligence, and when you're familiarizing yourself with the methodology for AI, these are a good place to start. First and foremost, searching algorithms are a key way to build out intelligent systems because AI needs to draw from databases, often quite large ones, of goals, solutions, parameters, rules, and perhaps even other key pieces of information. Searches need to be optimized for several reasons. First, the information being searched could be exhaustive and not practical in systems that need to optimize their decision-making process. A simple search is simply too slow and efficient. The A-star search algorithm is a popular and efficient programming method used in advanced path searches, and is popular because it's fast and it's accurate. Optimization, in a mathematical sense, is also a useful technique because it begins a search with a guess already posited, refining the guess until all options have been exhausted. These are often referred to as hill climbing and gradient descent algorithms because they can be visually represented as taking incremental steps, as in up a hill or in the steps of a gradient. Probability theory deals with the simple understanding that AI often works with little or no information to begin with. So several tools have been used that AI programmers leverage in the decision-making process. The Markov decision process, for example, is a method used to map probability based on steps in the process, relying only upon the current state of a step to determine outcomes. So, for example, during the Markov decision process, only the current step will be used to determine probability for future steps. Of course, each step before it got there in the same way. Next, there's logic, which is used for problem solving as well as other goals like planning, for example. Basically, logic is used for inference, drawing a conclusion based on the state of various parameters, and for representing knowledge, that is, coming to conclusions and even learning. There are several common methods for performing logic, such as true-false logic, known as propositional logic, first-order logic, fuzzy logic, subjective logic, and more. I won't attempt to explain all of these here, except to say that they typically use some form of true-false or Boolean determination, with options to characterize objects' properties, relationships, and more by isolating or quantifying them. Statistics also plays a large role in AI, one method used to train classifications. The other common method is through machine learning. Classification is the basic process of defining a thing. The pen is blue, for example. Classification, or classifiers, are a basic kind of AI algorithm, the other being controllers. In the pen example, a classifier determines that the pen is blue, and a controller would perform an action, for example, drop the pen. Neural networks were actually developed before artificial intelligence research began, and as the name suggests, they're based on the neural model of the brain, with interconnected nodes representing neurons. The interest in neural networks is based on the premise that if the human brain's decision and learning processes could be replicated in a computer, then those processes could be mimicked. And while early neural networks were impractical because they were slow, modern computer processing is exponentially faster than the computers in the 1960s and 70s. Today, deep neural networks use a layered approach to the neural paradigm and enhance AI systems with useful activities like vision processing, natural language processing, and much more. Recurrent neural networks are used to create deep learning in systems, and companies like Google and Apple have leveraged a form of deep neural networks called long short-term memory for all kinds of enhanced tasks like speech recognition and language translation. Other AI techniques that need to be considered include the programming languages commonly used in the development of AI, primarily Lisp and Prolog, which were both created with AI development in mind. Lisp is actually the second oldest high-level programming language and was introduced in 1959. Prolog was introduced in the 1970s, and it's a declarative language based on rules and relationships. Machine learning is a term that refers to the field of AI that focuses on machines that can improve their programming using techniques such as reinforced learning. Similar to positive and negative reinforcement found in psychology, this is simply a method for rewarding a system when it's correct and penalizing it when it's incorrect. Q-learning is such a system, providing rules and reinforcements for decisions made and creating policies based on those rules. Finally, natural language processing is an important field in AI research and development that focuses on how language is interpreted. While that sounds relatively simple, human languages are numerous and quite complex in their syntaxes, grammatical rules, and nuances. It's not as simple as using a set of grammar rules and providing a dictionary, and even systems that need to analyze written rather than spoken language involve complex coding that determines meaning using large libraries of information. The processing of semantics, the field concerned with meaning, continues to get faster, however, as computer processing power increases.